All right, section 9.5, dilations. This is talking about the transformations when you have a preimage and it gets bigger or it gets smaller. Those are called dilations. So there's a couple ways you can look at it. One way in this picture here, they're talking about how if you measure the distance from here to here, CR, which is right here, and you multiply it by what is called N, you're going to get this new distance here from C to R prime. That also works with the sides. This side, if you multiply that times a scale factor, or N, which is what we're going to be talking about today, you will also get your other side. So you need to remember the two different dilations. One is the enlargement, one is the reduction. And it happens when this N right here, I'm going to highlight that. That is called your scale factor. So when your scale factor is greater than 1, obviously you're going to get an enlargement. That makes sense. And if you have a scale factor less than 1, you're going to get a reduction. And if you're wondering, well, how do you find the scale factor? Like if I'm given just the two pictures or two lengths of sides, or even this distance and this distance, and I wanted to figure out, well, what was the scale factor? How many times bigger is it, or how many times smaller? You always put your image over your preimage. That's something you're going to want to really cement into your head. Image divided by the preimage. Okay? So when we look at this first question here, I'm going to go up closer. That is some small print. And my eyes are not seeing that too clearly. There we go. The dilation is an enlargement if the scale factor is greater than 1. We just said that. And the dilation is a reduction if the scale factor is between 0 and 1. So, yes, I should say that up there because it's not going to be a negative. That's not going to work. So it would have to be bigger than 0. So in this case, when we look at this, if we remember our image over preimage, and I will always be abbreviating it I over P, I can use the sides. So now I have to first figure out which one is my preimage and which one's my image. And I can tell that by the letters. This is A, B, C, and D, so that's my preimage. And this big one with the primes is my image. So I want the image one over the preimage. So I notice I have two sides. I have this side, and that's part of my image, so I'm going to put it there. And that's over my preimage, which is 2. And those are corresponding sides. So my scale factor is 2. Which is, of course, what they say here, but I'm trying to show you how they got it. Same thing here. If you do, again, the I over the P, image over preimage, and I look on here, again, where is my image? It's the ones without the prime, so it's the bigger one. I mean, the preimage, I'm sorry. And then the ones with the prime, that is the image. So, image over preimage. This side right here is 2 over the preimage. Corresponding side is 8. Reduce it, and we get 1/4. All right, so let's take a look at this. Boy, sorry about that. Shading looks shady to me. All right, J prime, K prime, L prime, M prime is a dilation image of JKLM. The center of the dilation is 0, or O, I should say. Is the dilation an enlargement or a reduction? What is the scale of it? Okay, so again, we need to remember always image over preimage. So we have to look at this and figure out which one's the image. Is it the bigger one or the smaller one? The smaller one is the image. And this bigger one was the original one they started with, which is your pre-image. Okay, so let's see, do we have 2 points? 0 is the center. Okay, I gotta see, do I have 2 sides? See, they don't directly give it to me like they did up here, but can I figure them out? Well, of course we could figure them out. You know, these slanted ones we could figure out using Pythagorean theorem, which I know every single one of you love to pieces. But we also have here vertical lines that we can use, so we'll use those. So if I count up, this is my blue one, that's my pre-image, so it's 1, 2, 3, 4. So that's my bottom number. My image is over here, so it's 1, 2. Simplify, it's 1/2. So would that be a, well, you can tell by the picture too. If I started with the blue and I went to the pink, is that an enlargement or a reduction? Correct, it's a reduction. You can also tell by the scale factor, which is 1/2, because it's less than 1. So, okay, got a couple more to do. Let's grab the other note sheet here. All right. Bye, Katie. She is going to Adoration. I highly recommend it. That all of you, as you get older, embrace an hour of adoration every week. Oh, wow, that was loud. Garage door, wasn't it? As you will find that the Adoration Chapel is the most peaceful place on the planet, and even when all of life isn't always great, you will find great peace when you're there. That's what I always wanted all my kids to learn, and I want you guys to learn that too. Jesus is always waiting for you there. And you can just be with him. You don't have to do anything special. You can just be with him. Okay, anyway, so I got a little distracted there. Let's head back to math. What are the images of the vertices of PZG? Okay, first of all, is the picture that is on there your pre-image or image? That is your pre-image. That's what we're starting with. And they're asking for the images of the vertices for a dilation with a center of 0, 0 and a scale factor of 1/2. So as soon as I see that, what kind of a dilation am I going to have? Correct. A reduction. It's going to get smaller, if that is even possible, because this picture is very small. But remember, if we're given coordinates, which we're not, we have to get them, so let's actually do that. P, G, Z. So P is, let's see, 2, 0. And G is 0, -2. And Z is 1, 2, -3, 1. And if I am going to try to get my images, which is P prime and G prime and Z prime, I need to do something with those. Does anybody have an idea what I might do with those coordinates? We are going to multiply them by the scale factor, because whenever you, before we were taking the image divided by the pre-image, and it gave us the scale factor. So let's just talk math for a minute here. Image divided by pre-image equals scale factor. So if I have, can't I think of this as a proportion? I can multiply these and multiply those. So the pre-image times the scale factor is equal to the image. I need an image. So I'm going to multiply the pre-image by the scale factor. Here's my pre-image. I'm going to multiply it by the scale factor. So we're just going to multiply these by a half, multiply by a half, and multiply by a half. And we will now get our images. And you just multiply each coordinate. 2 times a half, 1. 0 times a half, 0. 0 times a half, 0. Negative 2 times a half, negative 1. Negative 3 times a half, negative 3 halves. 1 times a half, 1 half. We officially have our answer. It didn't actually say to plot it. We could. But it asked you for the images, and there they are. Okay? All right, and the last one, the height of a document on your computer screen is 20.4 centimeters. When you change the zoom setting on your screen from 100% to 25%, the new image of your document is a dilation of the previous image with a scale factor of 0.25. What is the height of the new image? Okay, so they had the pre-image, which was the original, and we want to multiply it by the scale factor and get the image, just like what we did right here. So what was the original? 20.4, right here. Oops, we're not on the screen. There we go. 20.4 times the scale factor, which is, it got reduced to 25%, so change that to a decimal, and you get your image. So you guys can use your calculator or not. I am getting 5.1 centimeters. It is centimeters, right? Yeah, centimeters. That is when it's reduced by down to 25%. All right, so long.